first period class that I really should have done my nails before we did this activity, because you're going to get to see my hands like front and center. So disregard the fact that I'm in desperate need of a mani. All right, and I am recording this so that you can go back and refer to it if you need to. So we are doing our last type of rigid transformation, which is our rotations. And typically, the type of rotation that we were doing, you just rotated it around a point on the triangle. So let me show you what I'm talking about. So this clear piece of paper, it's actually officially used, to separate hamburger patties. That's why it's called like patty paper. I don't know if you've ever gotten those like stacks of hamburgers. And then somebody discovered, hey, it's actually pretty helpful for geometry because it's so see-through. So everybody start off, please, by putting your paper over problem number 1 and make yourself a copy of that triangle. So put the piece of patty paper over the top. I strongly suggest that you use the rulers as a straight edge, because the straighter your lines are, the easier this is going to be for you today. So everybody make a copy of your triangle and label it. Pretty please and thank you. So put the clear paper over the top of problem number 1. Make a copy. Label it EFG. I'm going to give everybody just a second before I continue. All right. So the types of rotations that the type of rotation you guys did a few days ago was a rotation where it actually rotated it around a coordinate that was on the triangle. So for example, don't do anything yet, but for example, maybe we rotated it around point F, which means that F stays put and the rest of it rotates around, right? So previously we did rotations where you were rotating it around a coordinate that was actually located on the shape. Today, we're not doing that because look at the directions. The directions say rotate 180 degrees about the origin. Where is the origin on a coordinate grid? Where is it?
0.
Yeah, it's at 0, 0. So friends, imagine, if you will, kind of visualize. Oh, I already did a crappy job putting that in the middle. All right, that your triangle is swinging on a swing, for lack of a better thing. So I'm going to use my straight edge to draw a line from the origin to that vertex. It does not matter. Somebody in my last class asked a great question. Does it matter whether you draw a line to coordinate G or could I have drawn it to F? It doesn't matter. So just as long as you're drawing a reference line from the origin to the triangle. So imagine, if you will, what's about to happen is that it's kind of like a merry-go-round. When you're on a merry-go-round, the middle stays put and you rotate around the merry-go-round, right? It's kind of what's getting ready to happen here. So step 1, make sure you've got a line drawn from the origin to a corner of your triangle. Although it,
to my straight edge.
oh, it's probably underneath there. Since they're clear, they kind of hide. They're hard to find. I didn't hear it drop, so.
Do we draw the line on the see-through paper?
And yes, I was just getting ready to say, here, Simone, I'll give you another one for right now. But it'll turn up. Oh, there it is. Okay. And then, yes, so she asked a great question. Now draw that same line on your copy. So you should have a reference line drawn from the origin. And technically, you could have drawn it to any corner on the triangle. I just happened to choose coordinate G. And you are going to, and then I made a copy of my reference line. It does not have to be perfect. Those of you guys that are perfectionists, you can tell even mine's not perfect, right? So, and that is okay. So what we're doing is we're holding the center still right here in the middle, And you're gonna, wee, it's like this is swinging around. It's like your line is swinging, 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 swinging. And how do I know that I have rotated this 180 degrees? Miss V is an excellent math teacher. How many degrees are in a straight line? 180, right? So see how my original line and my copy of my line form a straight line? That's how you know you've rotated it 180 degrees. Is that your original line and your copy form a straight line, which is 180 degrees. So this is the part, I suck at this enough. I really suck at this part. Making the copy on your paper, you just kind of have to like eyeball it and see where, like 1, 2, 3, 4. Okay, yeah. See where, so on my paper, so like point E is right here. So I'm just going to kind of lift up my paper. And I'm going to make, bless you. So you see that after I rotated it around, point E landed right there. So I just kind of lifted up my paper and I put the coordinate right there on my paper. I can see that coordinate F is going to be landed right here. So my F prime. And this part's tricky. You can see I'm not even doing a great job with it. Okay. And then finally my G prime, I'm just going to kind of lift up my paper. And my G prime is right here. And I'm going to connect my coordinates. So, step 1, I drew a reference line from the origin to, and it could be any corner of the triangle, okay? Didn't have to be coordinate G. Step 2, I made myself a copy. And then since it said to rotate 180 degrees, I held the origin steady. And I just went, rotated it around until my original line and my copy made a 180 degree angle, which is a straight line. And then I kind of just did the best job I could and lifted up the paper and put the coordinates where they belong. So, yes, dear.
Okay, could you have connected it to E even if it like overlapped a little?
1,000% yes. That is a great question. So Ren, correct me if I'm wrong. So you're saying, could you have drawn a line from here to here?
Yeah.
Yeah, you sure could. You can draw a line, and actually, we're going to see another example soon where your reference line is kind of have to go through the middle of it because you don't have a choice. Stay tuned for that. So this is obviously very easy to make mistakes, right? If you don't make your lines straight, if you kind of are off by just a little bit, if you're a terrible artist like me, there's lots of ways that you can screw this up. Thank goodness there is a way you can check your work by using number patterns. Because anytime you rotate a shape, and this rule only works for a rotation 180 degrees around the origin, okay? There's a different pattern for all the others. There's a reason we're going to take multiple days to do rotations, guys, because this one's doing a lot. You'll notice in your notebook, the due date for this isn't until Monday, because we're going to keep doing this Monday. So don't get stressed, because I know there's a lot of places to screw up. So let's check out the number pattern for the coordinates. So in my original G, my original coordinate for G was -2 and -3. And then notice that my coordinates for G prime are +2 and +3. So what do you notice about the numbers of the coordinates? Riley, what you got?
They're the, you said the word yesterday and I forgot it.
Oh, yeah.
Additive inverse.
Additive inverse. I love that connection. Thank you. Thank you.
Got it again.
Yep. And if you think about it, logically speaking, it makes sense. Because if the shape started out down here in quadrant 3 where everything's negative, and then it rotates 180 degrees over to the top right, well, obviously the symbol of everything is going to change, right? So whenever you are rotating a shape, and again, this only works if it's 180 degrees around the origin, you'll get exactly the same digits for your coordinates. It's just that they will be the additive inverse of each other. They'll be opposites. So you can check yourself to make sure you did it correctly by looking and making sure that the pattern holds true. Anybody not okay if I show you a different one, if I go over to number 2? Is anybody not okay with that? Okay, so I'm gonna flip my little paper over and we're gonna go, oh, here, I should probably mention this too. The 180 degrees, notice how it didn't tell me whether to go clockwise or counterclockwise, because 180 degrees, it really doesn't matter. If you go clockwise, you'll end up there, or counterclockwise, you end up in the same place. So typically, when it says 180 degrees, it won't give you a direction, because it doesn't matter whether you go counterclockwise or clockwise, you'll end up in the same place. Now, 90 degrees, like this one, is a different story because direction matters. And I'm sorry that thing's on my screen, but you guys have the paper. So this time it's asking us to go 90 degrees. The first thing I'm going to ask you to do is draw a reference line because once again, we are still rotating it around the origin. So use your ruler, use your straight edge. If I were you, I would draw my reference line probably using the y-axis because that's nice and easy. Because look, you could use whatever coordinate you want. You could draw it to, so I personally would draw it from the origin to V. That's where I drew mine. But you could have drawn it all the way down to U. It doesn't matter. You could have even drawn your reference line from there to W or to X. Doesn't matter. I just chose that one because it was on the axis and it was the closest. What do you think I'm getting ready to do next now that I've got a reference line?
Rotate it 90 degrees.
What do I have to do before I can rotate it? Because you're right. What else have I got to do first? I need a copy to rotate, right? So I'm going to make myself a copy. And make sure your copy includes the reference line. That is not a gray. I should have used a ruler. I just did the exact opposite I told you guys to do. Let's see. So we got V, U, W, and X. And then you're absolutely right, dear. So we're going to hold the middle and we're going to rotate. What direction is clockwise? Is clockwise going to go to the right or to the left? To the right. Yeah. Well, I see what you're saying because technically we're going like that way, but because of how this is, it's going to go like, so it is going to kind of go to the left. So you're right. It's clockwise, means like in this case, it's going to go like boop, like that, right? So you guys are totally right. Clockwise technically is moving to the right, but in this case, it's going to look like it's moving to the left you're exactly right. So clockwise, I'm going to hold this steady and go wee, swing it around. And I'm going to swing it until my original line and my new line form a 90-degree angle. And then I'm going to do my best to copy. So let's see, my V prime, my U prime. W and X. So I made my reference line. I made a copy of my shape and my reference line. I went wee, swung it around the origin until my original line and my new line formed a 90-degree angle, and I did the best job I could to make a copy. Well, that's probably not the best job I could do, but it's decent. Thank goodness there is a number pattern to help us out in this case too. So even though there's a lot of places it can go wrong, there is still a pattern. And I'm going to do more than one this time, ordered pair, because it makes it a little bit easier to see the pattern. So my original coordinate W was 2, -3. And my W prime is -3, 2. Oh, I'm sorry, -3, -2, my bad. My original coordinate U is 0, -5. And then my U coordinate is -5 and 0. So just look at those two. What do you notice, first of all? So let's look at our coordinate W versus our W prime. So our 2, -3, and then our -3, -2. So what happened to the digits? Like the 3 and the 2, what happened to them? They flip-flopped, okay? In algebra, because this is, algebra class in addition to 8th grade math, the way that we write the coordinates flipping with a symbol is it looks like this. We say we're going to flip-flop the X and the Y, okay? So that's the first thing that happened, is it went from 2, 3 to 3, 2. So the digits flipped, but then something else changed too. What is it?
The 2 became a -2.
The 2 became a -2 instead of a +2. Exactly. So step 1, they flip. Step 2, because here's them flip-flopped, right? Now instead of the X coordinate first, the Y coordinate goes in the front. And then we changed the sign of the right-hand side, okay? Who knows what the word kinesthetic means? What does it mean to be a kinesthetic learner? Do we know what that means?
No.
By like touching stuff or by movement? So this rule was always really hard for me to remember when I was in school. And because it's not the same, that's what makes rotations a pain in the butt. The rule is different for every type of rotation. So first of all, you flip-flop. Okay, so I always kind of did like a kinesthetic, so I flip-flop them. So my arms, I kind of cross them. And then because clockwise is going this way, right? Technically it's moving to the right if you start at the top of the clock. Which coordinate is it that changes? The one on the right-hand side. So that is how I remembered. That's how I kept straight. That when it's so look at my arm. So when it's a clockwise rotation, it's the coordinate on the right that changes its sign, not the coordinate on the left. So because it's clockwise and clockwise is that way, it's the coordinate on the right that switches. So I know that this is a lot to process. That's why this is the one we're taking the most amount of time for, okay? But the main reason I'm showing you the rule right now is because it'll help you to check yourself when you're doing it by hand. So I do want to go ahead and do number 4, because number 4 was kind of given. Oh, and let me actually write you a little note here. Number 3, are we rotating clockwise still, or are we rotating in the other direction? Okay, so when you rotate counterclockwise, it's almost the same rule. When it's 90 degrees counterclockwise, it's still, so step 1, you still flip the X and the Y coordinate. They still flip, but instead of the X coordinate symbol changing, now it's going to be the Y symbol changing. And the way, again, that I would always keep that straight is that counterclockwise is that direction. So it's the one on the left that changes. So the rule for a clockwise versus a counterclockwise is the same. except for they switch, the coordinates switch places, but instead of changing the symbol of the one on the right, since we're going counterclockwise, you change the symbol of the one on the left. Yes, dear?
So that's sort of like, I just thought of this, like with reflections, if you're reflecting across the x-axis, the y coordinate changes, and then vice versa. Is that kind of like?
It is exactly the same idea. The difference, though, I love that you made that connection. The difference, though, is that when you do a reflection, the numbers stay the same, right? They don't switch places, but yes, one of them flips. And I know every single transformation has a different rule, which is why we're going to spend several days practicing, guys, with all of them mixed together. So I know some of us, our heads are probably about to explode right now because I'm like, you know, I've introduced, 5 different rules, 6 different rules so far. For each one, we are going to practice because it is hard to keep track of, okay? I want to do number 4 because in first period block, that was the one that really gave people a hard time, and I totally get why. So go ahead and stop what you're doing for a second and look at number 4. So number 4 is still a 180-degree rotation around the origin. And what made this one a little bit tricky is that your reference line, because it's still rotating around the middle. So your reference line this time, though, is going to end up going like through the shape. So let me show you what I mean. And it doesn't matter which vertex you choose. You could have drawn a line from the origin to here. You could have drawn it to there, to there. Doesn't really matter. I just happened to, I chose to do coordinate R. So this time, your reference line is inside the shape, which makes that one a little tricky. So I'm going to make my copy, and I'm going to rotate it. And it's going to rotate on top of itself, which a lot of us don't like. We feel like it looks kind of messy, which it does. But it's still mathematically correct. So S, T, U. And then because it says to rotate it 180 degrees, I'm going to keep the origin straight. I'm going to rotate it around until my old line and my new line form a 180-degree angle, which is a straight line. And then I'm going to do the best job I can to copy the new one onto the paper. Let's see, did I line that up right? Yep. And finally, let's see, 1, 2, 3, 4, -2. See, some of you guys are probably like already done and you're sitting here waiting on me because I really suck at this. Doing it this way. So it's going to be a little messy. You're not going to like the looks of it because it's kind of rotated on top of itself. But it is correct. And you can double check, well, I think it's correct. Let me double check it by using coordinates. So my pre-image for my U was 1, 2, 3, 4, -2, right? And then my image is -4, +2. So yep, same coordinates. It's just their additive inverse. So I know I probably rotated it right. I see you, dear. I'm coming your way. Okay, so the easiest thing or the best way to do this is just for you guys to practice. Again, I strongly suggest you use pencils. Okay, I'm gonna shut up and